Hey folks, Mr. Dell here. We are looking at a problem where we have to do some rigid transformations. Actually, not rigid, just some transformations because it's going to include a dilation as well. So, not rigid. But yeah, so this is a question that I'm going to pull from here, CPM's course 3. And this is section 8.2.3, number 8-98. So it says graph these points, the x, y, and z, connect them and make a triangle, and then we're going to do a few transformations. We're going to do a reflection, we're going to do a translation, and then we're also going to do a dilation. Okay, so let's start by graphing. Remember, again, graphing, the two coordinates are, this is your y-axis, this is your x-axis, right? And coordinates are always written as x comma y, your x first, then your y. So this coordinate here, -5, or excuse me, -3, -5, x is -3, which is this direction, right? Your negatives are this way. This is -1, -2, -3. And then the y is 5. So it's at positive 1, 2, 3, 4, 5. So where those two grid lines meet, that lattice point there is where this point exists. And they're calling it capital X. It doesn't mean it's a this X, that X is the grid system. This is just a label for that point. Okay. The label for this point is Y, capital Y, but it's at -2, 3. So again, -2 on the X, 3 on the Y. So -2 is right here, right? Because that's -1, -2. And then 3 on the y is, let's see, 1, 2, 3 right here. So that was 5, that's 3. So the lattice point where those two coordinates meet is right there. So that would be my y. Okay. And then I'll do this, call that y. And then my x, my last one, my z, is at -1, positive 4. So right here. So a -1, 4. That's where that one is. So that's this little triangle here. So not a very big triangle, little triangle. So we're going to take that triangle and we're going to do a few things. One is we're going to reflect it across the y-axis. That's our first thing. Reflect across the y-axis. So that means this triangle will reflect across this axis as if the y-axis, that y-axis is the mirror. Like it's looking at itself, and what does it see? It's reflection over here. So there's a few ways to do a reflection. One way I tend to is I just go one point at a time. So if I start with this point closest to the y-axis, it's only one away from it, so it's still going to only be one away from it. So it's going to end up there. Oh, and that point, by the way, was z. I'm going to just label it real quick so we see that's the z. Okay. So this is my new z. And then the x, and notice it doesn't change y, um, its y term, right? Because it's going to stay horizontally here, but it reflects across. So it's 1, 2, 3 away. So it's going to be 1, 2, 3 away. So it reflects that's my new x, and we say x prime. Okay. And then the y here is 1, 2 away. So therefore it's going to be 2 away, 1, 2 away on the other side. So this is y prime. So this is the reflection across the y-axis. Notice it hasn't changed shape. It's just flipped around, if you will, or folded. If I took the paper and was able to fold the paper, it would be that mirror image on the other side, right? So then it asks me, what are the new coordinates of point z? Really, that z prime it wants. Where is that new z? The new z is at 1, 4. So the coordinates are at 1, 4. So that z prime is at 1, 4. That's my new z based on that reflection. Okay. B. Translate the original triangle. Okay, so we're going to translate the original one down 6 and 3 to the right. So that's going to look a little different. Right? So I'm going to take that one, and it's going to go down 6. So every point is going to go down 6 and 3 units to the right. So it's going to, this point here, this y is going to go down 6. 1, 2, 3, 4, 5, 6, right? So it's going to go 6 away. So 1, 2, 3, 1, 2, 3, 4, 5, 6. So right there. That's my new y. We call that y prime. And then, oh, oops, not yet actually, because I forgot. It's down 6 over 3. Oops. Ignore that real quick. Let me just so that way it doesn't get in the way. Let me do this. Use pen here. So, all right. So it's down. Okay. Try that one more time. Down 6. 1, 2, 3, 4, 5, 6. Right. And then it's over to the right 3. So right is this direction. 1, 2, 3. So actually, right there is my new y. That's my y prime. Down 6 over 3. So with the x, I do the same thing. Down 6, 1, 2, 3, 4, 5, 6 over 3. 1, 2, 3. So that's my new x. That's x prime. And then my z is down 3, down 6, 1, 2, 3, 4, 5, 6, and over 3. 1, 2, 3. So if you look, well, that's my new z. That's my z prime. If you see our triangle here, once again, the triangle hasn't changed shape. It's just been translated, shifted to a new location. Okay. So it wants to know what are the new coordinates for point y. So it wants to know my y prime. That's my y prime. So where's it at? Y is at x is 1. Y is down here at 1, 2, 3, 4. That's at -4. So x is 1, y is -4. Those are the new coordinates. So far, so good. And then C, dilate the original triangle by multiplying each coordinate by -1. Okay. So the dilation is taking a multiplier, a scale factor of the actual triangle itself. And my scale factor is -1. So I'm going to take each of those x's, each of these points. So my x prime now, my new x, I'm just going to write them out, it was -3, 5. So if I multiply everything times -1, that means take every x, multiply by -1. Take every y, multiply by -1, right? -1 times that, -1 times y. So I'm multiplying that by -1. So -1, that basically changes my sign. That becomes 3, -5. My y prime is now changes the sign to -3. And my z prime changes the sign. My z is -1, 4. So now it's at +1, -4. So I'll graph that. So let's see. 3, 1, 2, 3, -5. 1, 2, 3, 4, 5. So right there, that's my new x. Okay. And then y. So that's my x prime. Y prime is at 2, -3. So x is 2, y is -3. That's the lattice point there. That's my new y prime. And then z, the new z prime, is at 1, -4. Right there. So that's my new z prime. So this is the triangle that we get after we dilate. So multiply by that scale factor. It says describe the new shape. Well, the new shape, it didn't change its size. It's the same size, just I would say what we could say is the description is it looks like it's reflected across the x and the y axis. So it reflects across x. Oops, I should have one C there. Sorry. Reflects across the x and y axes, right? So if you think about what happened here, is it reflected here? There's the reflection across the y-axis, and if you notice, it reflects also across the x-axis. You see how it flips around there, and it flips again around there. So it reflects across the x and y-axis. That's my description, but it's still the same size. Same size. All right, there we go.